Hi everybody and welcome. Today we're going to be talking about systems of linear equality. So after watching this video, you should be able to graph multiple inequalities and find the points and regions where they intersect. So to start off, what is a system of inequalities? So let's write that down here. Looks like my pen is not working. Give me a moment. But again, the big idea here and the big change from what we were doing previously is instead of graphing one inequality, we're going to be graphing multiple inequalities at the same time. And we're going to see here, they're not going to intersect just at one point, but we're going to have entire regions where they intersect. All right, success. So I'm starting off a system here. Of linear inequalities. So again, this is where we have at least two inequalities that overlap. And a quick reminder here of the different types of inequalities that we have. So let's say, for instance, we have y equals 2x plus 1. When we were to graph this, this is just a line. We would see we'd start off at 1, we'd go up 2 and over 1, and we'd have a line that would look something like this. But let's draw this in the multiple different ways that we can do this with inequalities now. We'll use the same numbers for simplicity's sake. So if we have y is greater than 2x plus 1, well, the greater than sign, that means that we're going to be shading above, and it's not or equal to, so that means it's going to be a dashed line. So same idea, start off at plus 1, we go up 2 and over 1. We're going to be, again, a dashed line here, shading above it, so I always draw those arrows that go up, and that's going to be our solution. All right, now let's take a look at a second example. What if we had y is less than 2x plus 1? Well, in this case, we're shading below because it's less than, and it's still dashed because, again, we have that less than sign. So it's not equal to any points on this line. So we're going to see this here. Again, it is shaded below, so I always draw the arrows going down to just remind myself when I go to shade. Okay, so those are the two big examples. If we were to make it or equal to, we would change it from dashed to solid, and that would mean that we would now make this into a solid line. Same thing here. If it is or equal to, instead of just less than, we change it to solid. So now what we're going to be doing is putting two of these graphs at the same time onto a graph, and we're going to see where do the regions intersect. So the big change here is instead of what we were doing before, which is shading right away, we're going to hold off and wait on our shading until we have both of these done. So let's take a question like this. We're going to have y equals 4x minus 2 as 1. Instead of equals, I should write an inequality. Sorry about that. We'll have y is less than 4x minus 2 is 1, and then we'll have y is greater than negative 1x, or negative x is our second one. So quick things to note about both of these, we're shading above, and this one is dashed. So let's go ahead and do that. So it goes down 1 over 1, and our intercept is 0. So this line here is a dashed line, and we're going to be shading above it, so I always put little marks here. Again, that way we don't forget this region we're shading above. For our second one here, we're shading below because it's less than, and it's actually also dashed because it's not or equal to. So this one we start off at our b is negative 2, and then we go up 4, our slope, and then over by 1. Like so. Okay, so again, we are dashed. And this one, again, shading below. So find your point, and we're going to be shading directly below it. All right. And then finally, for our systems, the only place where we shade is where both regions come together. So for example, if we do the entire yellow region for this line that we're shading below, and then we can do an entire green region for this line that we shade above on, what you're going to see here, hopefully pretty visually clearly, is there is a region where both of these things are shaded. And the place where both of those things are shaded, that is where they intersect. I'll put that in black. So this is the region where these lines have solutions that are the same, that intersect. And technically, we shouldn't have shaded anything else. So that right there is just going to be our answer. And to be even more clear, anything that's in that region is an answer. So if you were to take this point here, that's a solution. Anything at all that is shaded is an answer. The only exception is these are dashed lines, which means we can't have any solutions that are actually on the lines themselves because it is not equal to. It's just greater or less than. So for example, we could say a solution to this is 1, 2, 3, 4, up to 4, 2 is a solution. Literally any point that is on the shaded region is a solution. And that's what we're going to be working towards today. So that's an example of two shaded lines coming together. And for the next video, we're going to be talking about what happens when you have more than two.